In this video, I'm going to be working AP Pre-Cal Homework 0.2, and I'm just trying to stay out of the sun. It's going to be all about quadratics and factoring and solving degree 2 polynomials, but only by factoring. So we're going to solve the equation, we're going to show the work that leads to our answer. That's our standard. So we're always in this class going to start by looking for a greatest common factor. That's what's going to happen with this first one, number 1a. X squared and negative 6x, they both have an x in them. So I factor out the x, and I'm left with an x minus 6. Because I think, what do I multiply x by to get x squared? That would be an x. And what do I multiply x by to get negative 6x? And that would be negative 6. It's still equal to 0. Okay, if it wasn't already set equal to 0, I would need to do some work to make sure it was equal to 0 first. I'm sure that'll happen later in this problem set. Okay, but now that I've got two things multiplied together equaling to 0, I can say one of them has to be equal to 0. So it's either the case that x is equal to 0, or it's the case that x minus 6 is equal to 0. And if x minus 6 is equal to 0, that would mean that x had to equal 6. For b, I'm going to do the same thing. I'm going to say what's common to both of these terms? The x. So I factor out the x, and I'm left with an x and a positive 9. And if I've got two things multiplied together to equal 0, one of them has to equal 0, so it's either the case that x is equal to 0, or x plus 9 is equal to 0, and that would happen only if x was negative 9. So I've got 0 and negative 9 as my answers. So if x is a greatest common factor, we'll see that x equals 0 is going to be a solution, provided the thing set to 0 in the first place. In these next couple, kind of the same idea. I think we're just going to be factoring out an x, but on c, I see also there's a negative 4 common to both, because 4 would divide 16, they're both negative. Let's deal with that negativity right now. Factor out the negative 4 and an x, and what do I multiply negative 4x by to get negative 4x squared? Just another x. So I'd have x and then a positive 4, right? Because I would need to multiply negative 4x by positive 4 to get negative 16x. Okay, so it's either going to be the case that negative 4x equals 0 or x plus 4 is equal to 0. And negative 4x would only equal 0 if x was 0. So I've got x equals 0 or x equals negative 4. Okay, I don't love this problem because I always try to make sure that that coefficient that we pull out, let me just use a highlighter to show you what I'm talking about. I try to make sure that's not a 0 because sometimes people will want that to be an additional 0. Definitely on the quiz it says it's not going to happen like that because I'm trying to make sure you don't make that error, that you know what you're doing. This one, the zeros were, or the solutions to the equation were 0 and negative 4. For D, I'm seeing a 3 and an x common to both terms, and so I'd have 3 and a negative x. And we don't need to necessarily reverse the order or anything, because we can solve this the way it's written. Okay, so either 3x equals 0, it would only happen when x was 0, or 3 minus x would equal 0, and that would be where x equals 3. So again, that coefficient that we factored out did end up being a 0, but that's just a coincidence. That's just because probably I was being lazy when I wrote the question or didn't think about how it was going to play out. Okay, number 2, they're going to prompt us with a function f of x, which is x squared minus 8x. If we want the zeros of f, that's just where f of x is equal to 0. So I'm going to say f of x equals 0. That's what that terminology means. And then I'm going to say, all right, x squared minus 8x equals 0. Again, I'm going to factor out that x. Okay, and these two things, they could multiply together to equal 0 if one of them was 0. So I'd either have x equaling 0, or I would have x minus 8 equaling 0, which would only happen when x was 8. Okay, f of negative 3, talked about this last time and in the last homework. We're just going to replace x with negative 3 wherever we see it in the formula. So f of negative 3 equals negative 3 squared minus 8 times negative 3. Right, so let's make sure that's on screen. Negative 3 times negative 3 is going to be positive 9. Negative 8 times negative 3 is positive 24. So I add those together and I'll get 33. Okay. Solve the equation f of x equals 9. So that would be f of x is x squared plus 8x, and that will equal 9. That's what I was saying earlier. If the thing's not set equal to 0 and it's a degree, and not just degree 2, this will apply more generally. if I have more than one different power of x floating around at the same time, I got to try factoring. And so, and I got to set it equal to 0. So I'm going to subtract 9 from both sides. Get x squared plus 8x minus 9 equals 0. Now I'm going to try to factor. But I think, what are two numbers that multiply at a negative 9? To me, the first thing that comes to mind is 3 and 3, right? Or 3 and negative 3. But that's not going to work here because they need to add 8. So it's going to be somehow 9 and 1. Maybe positive 9, negative 1, because it needs to add to positive 8. So x plus 9 times x minus 1 needs to equal 0. And if these two things are multiplied together to equal 0, one of them has to be 0. So either x plus 9 is equal to 0. That would mean x was negative 9. Or x minus 1 is equal to 0, and that would happen when x was 1. And then if we're solving the equation f of x equals negative 16, which there you can see it, we're going to do the exact same thing. So that's x squared plus 8x equals negative 16. I'm going to set this thing to 0 by adding 16 to both sides. About what are two numbers that multiply to 16 and add to 8? That would be 4 and 4. So you have x plus 4 multiplied by x plus 4. Okay, and so we can see that, okay, either x plus 4 is equal to 0 or x plus 4 is equal to 0. So that's, okay, well, we already knew x plus 4 is going to potentially be equal to 0. So the second factor, it didn't give us an additional solution. But I think we'll talk more about multiplicity of solutions at a different time. Yeah, I think once we actually talk about polynomials in general. So I'm just going to say, okay, well, this is only going to happen when x is negative 4. Important for me to remind you that, degree 2 polynomial can have 2 solutions or it can have 1 solution. It can also have 0 real solutions. But then I think next time we'll go in and realize that if it's got 0 real solutions, maybe if we look a little harder and think about imaginary numbers, we can always find 2 solutions up to including multiplicity, like this was a double solution there. But more on that later in the course. We're not worried about that today. Okay. Number 3, back to, here it is, solve it. It's not a whole lot of room. Hopefully you're able to solve in this amount of space. If you're not, you should pull out an extra sheet of paper. There's no shame in having to use more paper, right? That's what there is shame in, is trying to cram in all of our work and then having something that's pretty much useless to go back and look at later. Okay, that would be a shame. So x squared minus 5x plus 6 equals 0. We're looking for two numbers that multiply to positive 6, add to negative 5. I'm thinking negative 3 and negative 2. That will be giving me either x equals 3 or x equals 2. This next one, x squared plus 10 equals negative 7x, not set to 0. We're going to need to do some work to set it to 0. It won't be that hard. I'll add 7x to both sides. And we generally like to do ax squared plus bx plus c. Make it always kind of look the same, make our factoring as easy as possible on us. Thinking about two numbers that multiply to 10 and add to 7, 5 and 2. So I'm going to say this is going to be x plus 5 multiplied by x plus 2. And that'll equal 0. And then if x plus 5 is equal to 0, that's x equaling negative 5. If x plus 2 equals 0, that would only happen when x was negative 2. So I've got 2 solutions. Okay. C, I see 2, 6, and 8. Those are all even numbers, so I must have a greatest common factor. Okay, there's not an x in all 3, so I'm not going to be able to factor out an x, but I will be able to factor out that 2. That 2 there, but I'm going to think, what are two numbers that multiply to negative 4 while adding to 3? So it's going to be 4 and 1. If it's positive 3, it'll be positive 4 and negative 1. Got it fully factored. We can apply the zero product property and say, all right, well, one of these 3 things has to be 0. Either it's the case that 2 is equal to 0, which we know it's not. Okay, so there's no solution there. Or x plus 4 is equal to 0, which gives me x equals negative 4. Maybe x minus 1 equals 0, that would give me x equals 1, and that'll be my solutions. Okay, it would also be a bad sign if you saw 3 solutions to a degree 2 polynomial. Okay, algebra 2, hopefully they at least told you about the fundamental theorem of algebra. Hopefully you didn't work too much with it, because actually proving that theorem is an extremely advanced problem. But an nth degree polynomial will have n solutions up to including multiplicity, complex roots, things like that. 4x squared plus 8x plus 12, we're going to have to set to 0 first. Then we're probably looking for a greatest common factor. Yes, I'm seeing 4 in all three terms. So 4 times x squared plus 2x minus 3. So I hold on to the 4. And two numbers that multiply to negative 3 while adding to positive 2 would be x plus 3, x minus 1. So either 4 equals 0, which it doesn't, or x plus 3 equals 0, or x minus 1 equals 0. That would be where x was equal to 1. All right, E, F, G, H. This one just keeps going, doesn't it? Okay. All right, so I'm looking at E, and I'm seeing 2x squared minus 11x plus 15 equals 0. And 2 doesn't divide negative 11 or 15, so this is one of these where we're going to have to factor without getting rid of the 2. So we're going to multiply the 2 and the 15. This one was in the notes also, but we can do it again. It's never bad to keep practicing. So I'm looking for two numbers that multiply to 2 times 15 is 30, so u times w equals 30. And they need to add to negative 11. So I'm thinking negative 6 and negative 5. Maybe this is slightly different. Somehow maybe it's positive 11 or something on the notes. But, this is something we'll be able to do. We'll split up the negative 11x into negative 6x and negative 5x. So, okay, because 6 is divisible by 2 and 15 is divisible by 5, I'm going to line up the negative 6 here and the negative 5 there. But that, I got to say, that's not necessary. You don't have to do that. I just see where I'm going with this, and I want the factoring to be as easy as possible. If you did negative 5x minus 6x, you would still get the same thing, provided you did the group and factor step correctly. Oops, kind of ran out of room there. But then I'm going to take the first 2 and say what's common, the 2x, and I'm left with x minus 3. And then the negative 5x plus 15, I'm trying to go for something that will give me x minus 3. So what I need to do is factor out a negative 5. Okay, so I'll have minus 5. Okay, multiply that by x and by minus 3 to get positive 15. And then I can factor out the x minus 3, be left with a 2x minus 5. And I'll have, okay, either it's the case that x minus 3 equals 0, that would be x equals 3, or 2x minus 5 equals 0. Okay, what's a number that I could double and get it equal to 5? That would be 2.5. And in this class, it would be perfectly valid for you to call that 2.5, right? We don't have to call that 5 over 2. They're the same number. Okay, 10 over 4, that needs to be simplified. Okay, but that's the standard for simplification on free response is something that we will talk about more and more as time goes on. We'll be less strict at the beginning of the course, more strict at the end to prepare you for the AP exam, right? But this won't be built up in a day, right? We've got the whole year to work on this stuff, and we're going to take it. Okay, for F, I'm seeing the same thing. 2 doesn't divide that negative 5, so I'm going to have to use the same technique. And maybe I can scroll over a little bit. Yeah, that'll help. All right, so I'm looking for two numbers that multiply to 2 times negative 12 is negative 24, while adding to negative 5. Okay, so I'm thinking 8 and 3 somehow. Maybe negative 8, positive 3. Okay, so I'm going to split up that middle term. 2x squared minus 8x plus 3x and a minus 12 equaling 0. Okay, group and factor from the first 2, I see the 2x. From the second 2, I've got that 3. This gave me an x minus 4, so I know I'm on the right track. If I didn't see that same binomial, that's a bad sign. It means you've done something wrong. I need to double check. Okay, then I factor out the x minus 4, and I'm left with a 2x plus 3. So it's either the case that x minus 4 is equal to 0, that would give me x minus 4, or 2x plus 3 equals 0. This is one, I don't know, maybe it's best that we take this off to the side and solve this the old-fashioned way. X equals negative 3 divided by 2. Okay. All right. Looks like we we got a couple more of these, and if you're sitting there thinking like, dude, I got it, I know how to factor these, feel free to skip these two, right? Like, hopefully you're using this video to check your solutions, not necessarily to just copy off of them. That would not be the best form of practice. It sure would be better than nothing, but I'm telling you, it's not a whole lot better than nothing. So this one, we're going to set it equal to 0, but if you're good with this, feel free to fast forward, right? No judgment. The idea with homework is it's practice. You're going to practice until you feel confident, not necessarily until you've done every problem that I put on the booklet of problems. That might be a distinction from last year too, is that we're not necessarily going for every problem, we're going for understanding. All right, so I think that's enough of that. I think I might have been stalling because I didn't necessarily want to keep doing these, but I was the one that put them on the homework, so I should be willing to do them, right? Okay, so I'm looking for two numbers that multiply to negative 14. While adding to positive 13. All right, that shouldn't be too bad. So that'll be 13 and negative 1. What? No, 13 times negative 1 is not equal to 14. I'm thinking probably 14 and negative 1. Yeah, that makes more sense. So I'll split up that middle term. 7x squared plus 14x. And you know what? I'm going to do it the other way this time, just to show you that it really doesn't matter. Okay, because 7 and 14, that feels parallel, and negative 1 and negative 2, they both have negative in them, so you might want to put those together, but I just want to show you that it really does not matter. Plus 14x minus 2 equals 0. I'm still going to do group and factor. What's common to 7x squared minus x? Well, just that x, and I'd have 7x minus 1. And then the 14x and the minus 2. I guess just the 2 is common to those because they're both even. So I'd have 2 times 7x minus 1. So it's going to work out regardless. I factor out the 7x minus 1, be left with an x and a positive 2. Set that equal to 0. That'll give me, okay, x plus 2 equals 0. I can see that'll be x equals negative 2. 7x minus 1 would equal 0 if 7x was equal to 1. And that would happen if x was 1/7. I mostly did that verbally or mentally because I didn't have room to, but if you want to do that by hand, you should totally do that by hand. Okay, last one of these. We're going to subtract the 22x and subtract the 15, set it to 0. And yeah, man. Okay, looking for two numbers that multiply to 5 times 15 is 5 times negative 15. That would be 75, 15, 30, 45, 60, 75. I don't know. If you're like me, hopefully, I hope you didn't forget how to count by numbers from elementary school, because that's pretty much, that's how I do arithmetic. I find it to be very useful. And counting by 15 is useful. I don't know if it's all that useful, but in this case it certainly is. So u times w will be negative 75, and u plus w would equal negative 22. So 75 and 1, 25 and 3. I mean, I'm sure there's 5 times 15, right? But that wouldn't add to 22. I think 25 and 3 is going to be the winner, and so it'd be negative 25, positive 3. Okay. And then I'm going to split up that negative 22 into the negative 25 and the positive 3. Still subtracting the 15, and that's going to equal 0. Okay, with 5x squared plus minus 25x, what's common to those? The 5 and the x. Be left with an x to 5x squared and a negative 5 to get to negative 25x. And then from 3x and negative 15, 3 divides 15, so I'll factor that out and be left with that same x minus 5. So then on these, I'll factor out the x minus 5 and be left with 5x and a positive 3. And so now that I've got it fully factored, I can apply the zero product property and say, all right, if these two things multiply together to equal 0, one of them has to be 0, so it's either the case that x minus 5 equals 0, which would give me x equals 5, or 5x plus 3 equals 0, which might be something we could do off to the side, right? If we needed to. If you don't need to, feel free to just go straight to what is it going to be? X equals negative 3/5. But I could really see you saying it was negative 5/3 or 5/3 or something if you weren't careful here, so it might be worth the extra effort. And that's those are our two solutions. All right, that was a little grueling, but we're done now, so guess we'll be happy with that. All right, g of x equals 4x multiplied by x plus 5. G can be written as ax squared plus bx plus c. Find the values of a and b and c. All right, we're going to do this. So what we're going to do is do the distribution. 4x multiplied by x would be 4x squared. And 4x multiplied by 5 would be 20x. Okay, I'm not going to have anything else, so one of these things is going to have to be 0. The number of x squareds is 4. The number of x's is equal to 20. And the number of numbers on the outside, well, there's no numbers on the outside the x's, so that'll just be 0. Okay, y-intercept on the graph of g, that's the value of g of 0. So I would just say that's 4 times 0 plus 5, and that's 0. Find all x-intercepts on the graph of g. Well, it's already factored, so that's pretty convenient. 4x times x plus 5. We're gonna set g of x equal to 0. And you know, I think I've been a little lazy here. Probably should have said y-intercept. That is a highlighter, pardon me. Y-intercept, that's where x equals 0. And an x-intercept, whoops, pardon me, toolbar is showing. My x-intercepts, that'll be where y equals 0. Okay. But I didn't actually find the values of x. And just to emphasize down here, g of 0 equals 0, that means my y-intercept is y equals 0 from that 0 right there. Okay, for these, I'd either have 4x equaling 0, so that would give me x equals 0, or x plus 5 would be equal 0, and that would be x equaling negative 5. G of negative 2, maybe I'll try to leave that on screen. Yeah, 4x times x plus 5. So let's just say g of negative 2 is going to equal 4 times negative 2 multiplied by negative 2 plus 5 is 3. So I got negative 8 times 3 would be negative 24. Okay, and if I was going to solve the equation g of x equals 24, I would probably be best to, because I'm going to need this one of those where I need to distribute it out, then set it equal to 0 and refactor. So I'd probably be best to use the distributed version of this equation. By that I mean like that 4x squared plus 20x. So I'll go over here and I'll say 4x to the 2 plus 20 times x to the 1, that's going to equal 24. Set this thing equal to 0 so I can hopefully solve. I'm going to just like really enlarge this, I think. So some more room to work. Set it equal to 0. 4x squared plus 20x minus 24 is equal to 0. And I see 4 in all of this because 4 divides 20 and negative 24, so I'm going to factor out that greatest common factor. I'm going to say 4 multiplied by x squared plus 5x minus 6 is equal to 0. And then the 5 and the 6 is where we got to be careful, right? We're thinking of two numbers that multiply to negative 6 while adding to positive 5. So, 3 and 2 sounds appealing, but it would need to be like positive 3, negative 2, or negative 3, positive 2. Neither of those will add up to 5, so it's got to be 6 and 1. So I think it's going to be positive 6, negative 1, yeah. So x and positive 6, x and negative 1, that's equal to 0. If these three things are multiplying together to equal 0, one of them has to equal 0. Either 4 is equal to 0, which it doesn't, or x plus 6 equals 0, or x minus 1 equals 0. And those will be my solutions to that equation. All right, number 5 looks very similar. T minus 3 to the second power minus 2t. We're going to write it in standard form, find the values a and b and c. All right, so t minus 3 squared is going to be t minus 3 times t minus 3. And I might just actually write that out and then subtract 2t. All right, so if I do the distribution, I'll have t squared, negative 3t, another negative 3t for a total of negative 6t. Plus 9 minus 2t. Now I'm going to combine like terms. I see this negative 6t and that negative 2t, so I'll need to combine along those lines and say, all right, I've got t squared minus 8t plus 9. Okay, and so that's h of t, and the value of a would be 1, because it's 1t squared, b would be negative 8, negative 8t, and c is positive 9. Okay. Solve the equation h of t equals 18. Okay. Well, if it's set equal to something that's not 0, I'm going to need to have the distributed version, and I think I used this kind of highlighter last time for that, so I'm just going to use the distributed version and set it equal to 18. Not equals 0, equals 18. All right, and now I'm going to subtract 18 from both sides. Minus 8t, 9 minus 18 would be negative 9. So I'm looking for two numbers that multiply to negative 9 while adding to negative 8. That feels like negative 9 and positive 1 to me. If t minus 9 times t plus 1 is equal to 0, either t minus 9 is equal to 0, or maybe t plus 1 is equal to 0. And those would be my the t values of my solutions to that equation. If k is the function defined by k of t equals t squared plus 5, what value of t makes h equal to k? Okay, well, I've got a formula for h, and I should probably use the distributed version, so t squared, so I'm going to just actually start with the equation they gave me, h equals k. Formula for h is going to be, I'll use blue, or that kind of teal color. Whoops, that's a highlighter, not a pen again, so t squared minus 8t minus 9 is equal to k, which they told us is equal to t squared plus 5. And then if I go to solve this equation, this is actually not going to be so hard. We don't even have to do factoring on this one. We'll be able to directly solve. Because maybe you go to set this thing equal to 0 because you don't see what's going to happen. You're going to subtract t squared from both sides, and then both of the t squareds will be gone. Right? If you subtract t squared from the left side, t squared from the right side, all of a sudden you have no t squared. Okay, so I'll have negative 8t minus 9 equals 5. Maybe I'll try to get rid of that 9 by adding 9 to both sides. So negative 8t equals 9 plus 5, which is 14. And I'll divide both sides by negative 8, and I'll get t equals 14 divided by negative 8. Those are both even numbers, so I know I can go farther. I can simplify. So I'm going to say that's 7 over negative 4. 7 over negative 4 is fine. You can call that negative 7 over positive 4, however you want it. But we do need to simplify that. This next question is interesting. This one's a little different from what I saw on my notes. Makes me wonder if this is on the quiz. The lengths of a scalene triangle, I don't see a triangle drawn, so I might as well just draw one myself. Scalene means all three of the sides are different, and I don't know, that could very well be a scalene triangle, and we're just going to assume it is. So the side lengths are 3x to the 2 plus 2x, x to the 2 plus 4, and a 2x squared. How many values of x make the perimeter of the triangle equal to 12? Well, 12 is equal to the perimeter, and we can get that by adding everything together. 3x squared plus 2x plus x squared plus 4, and a 2x to the 2. We'll need to combine some like terms, right? In terms of the squares, I've got 3 and 1 is 4 and 2 is 6. Eventually, I guess I'll need to set this equal to 0, but I think first I need to combine some like terms. In terms of x's, okay, I guess I've only got this 2x and then a 4. Okay. I'm hoping to solve this because I've got more than one power of x moving at the same time. I'm going to need to set it equal to 0. And so I'm going to say 0 equals 6x squared plus 2x. 4 minus 12 would be negative 8. And unfortunately, I'm seeing, well, although there is a greatest common factor of 2, I'm still going to have a leading coefficient. That's kind of unfortunate. But I'll tell you, way better to factor that out first and deal with the simplified version. I think I'm just going to ask you to trust me on that. So x squared plus, wait, no, 3x squared. I wish I could have factored out the 6, but then I wouldn't have been able to factor it any further. 2 times 3x squared plus an x minus 4. Oh yeah, this is kind of an interesting one, so I'll need to, figure out two numbers, u and w, that multiply to equal 3 times negative 4, while adding to equal positive 1. So I think this is going to be 4 and 3, kind of like I saw, but I think it'll be positive 4 and negative 3, yeah. So I'm going to go over here, and I've still got this 2, which really isn't contributing anything. You could divide both sides by 2, but I like to hold on to those. 3x squared minus 3x plus 4x minus 4. Okay, 2 times what comes out of the first 2, that would be, well, hold on. That's going to be a 3 and an x times x minus 1 plus a 4 times x minus 1. And then that's a 0 equals 2 times x minus 1 times 3x plus 4. This one was a bit of a slog. But you know, there's going to be some multi-step problems in this class, you know, like I'm not going to lie to you about what we're up against. There's going to be some hard problems, and I'm also telling you there's going to be some really accessible problems, which is going to be kind of our code word for easy. We're going to have a diverse array of problems that you're going to be confronted with in this class, and not all of them are going to be easy, not all of them are going to be hard, but this is going to be one of the harder ones, at least for this lesson. Okay, so either 2 equals 0, which we know it doesn't, or x minus 1 equals 0, or 3x plus 4 equals 0. 3x equals negative 4, x is negative 4/3. Okay, so it asked how many values of x make the perimeter of the triangle equal to 12. And the thing I worry about is, like, what if the negative 4/3 caused one of the side lengths to be negative? Now, obviously, 2x squared is going to be positive for any non-zero value of x. X squared plus 4, same story. But the 3x squared plus 2x has me a little bit worried. So let me do a little bit of checking off to the side just to make myself, you know, not feel bad. So what I have to do is think about 3x squared. Squared plus 2 times negative 4/3. Okay, well, if I square negative 4/3, I get positive 16 over 9 plus negative 8 over 3. I can simplify that to be a 1 and a 3. 16 minus 8, okay, so that's positive. Okay, so both of these are working fine for me. Right, so I'm going to say 2 values of x. How many values of x? 2 of them. Okay. But the analysis that leads to my conclusion, that's all that work in black and blue and red. Okay, and there's going to need to be quite a bit of work on that one. And that might be one that I spot check to make sure that we're, you know, browsing through the homework, not just doing the front page, not just doing the ones that look easy, kind of getting a diverse array of practice. So I'll be looking to see if you did that one. All right, number 7, I think this is the last page. I'm hoping this is the last page. And this one, we'll have to square the x minus 3. That'd be x squared minus 6x plus 9. Add, not add. Subtract 2x and say that's equal to 9. We're going to combine like terms. Negative 6 minus 2 would be negative 8x plus 9 equals 9, not 0. Got ahead of myself. I know I'm going to need to set it equal to 0, so I'm going to subtract 9 from both sides. And it's like, ah, great. This is nice. Factoring won't be too bad. I'm going to factor out the greatest common factor of x, be left with an x minus 8. And I'll say either x is equal to 0 or x minus 8 is equal to 0. And that would give me a couple of solutions to that equation. Okay, this next one here, I'm going to do the distribution. Okay, so x plus 2, x minus 5. I'm going to have an x squared. 2 minus 5 is negative 3x, and 2 times negative 5 is negative 10. Okay, so combining some terms, 10 and 18 would be negative 28. I don't know about you, but I think the only ones I know, well, I guess there's 14 and 2 also, but I think 7 times 4, right, is 28. And that that can combine to give me a 3. So I'd say negative 7, positive 4. So that'll be either x minus 7 equaling 0 or x plus 4 equaling 0. Okay. Now number 8. This is going to be all yes. All right. So x and y intercepts on the graph of this function, which you are now able to see. So I would say x-intercept. That's where y equals 0. Okay, so 0 for y equals negative 3 times x plus 4 and x minus 5. Okay, it's already factored for us, so we don't need to do anything else. We just apply the property, 0 product, say that either negative 3 is 0, which which it isn't, or x plus 4 equals 0. That would be when x was -4, or maybe x minus 5 equals 0, and that would be where x equals 5. Those are my x-intercepts. For a y-intercept, that's going to be where x equals 0. And that's going to be, we've got a formula for y in terms of x, so we'll just plug in there. And so y will equal -3 times 0 plus 4 times 0 minus 5. All right, so -12 times -5, that would be positive 60. And that would be my y-intercept. Function, yes, I know what this is getting at. Write the function f of x equals x minus 2 times x minus 1 minus 12 in an equivalent form that displays the zeros of the function as constants or coefficients in the expression. That's some weird terminology. That wasn't in the notes, right? So it must be somewhere else, right? And I'll just tell you, this is very much like a multiple choice question. So this is your preview, right? That's the point of the homework, is to practice, to prepare you for the assessments, for the quiz, for the test and everything. Oftentimes, if there's one that I'm going to put directly on there that's almost identical to a test question or a quiz question, it'll be at the end of the homework. So I want to reward you for, doing all your practice. I don't say that you need to do all of the practice problems. But that said, what was I? I kind of lost myself. Oh, but, if you do all of them, it will benefit you. Okay, that's my point. So, displays the zeros of the function. If you look at the factored form of a quadratic, it can kind of show you the functions, right? Or the zeros of the function. It's in there. Where are they? We just did one. Okay, right here. So, same thing. X plus 4 and x minus 5 somehow displayed the zeros in the equation. So what we need to do is basically just write this thing in fully factored form. And so that will involve us distributing x minus 2 times x minus 1 would be x squared. -2 minus 1 is -3x plus 2 minus 12. Combine those terms. Think about two numbers that multiply -10 while adding -3. It feels like -5, +2. So x minus 5, x plus 2, and that's an equivalent form. So I'd say, all right, f of x equals this. The zeros are going to be 5 and -2, and that's they're displayed like we were saying. You just connect back to what I was saying earlier. That's them displayed. And yep, that's all for this homework. So that's going to be all for this video. Thanks for watching. Hope it helped.